Hi everyone, in today's video I'm going to explain if a causal relationship can be derived from correlational research or differential research. And before I do that, I will explain again what correlational research is, what differential research is, and again what causal relationships mean. Alright, so let's take any research example where you are trying to establish a relationship between two variables. And I will stick to the same example so that you can understand it from a more holistic perspective. Alright, so here let's say one example is that you are trying to establish if there is a relationship between better reading skills in students and if there is a relationship with higher or better ability in solving math related problems. So you are trying to find a relationship where if students are better at reading, does that mean they are also better at solving math problem? So if you're trying to find a relationship between these two variables, it's kind of correlational research, right? Now, how we assign participants and how we differentiate two groups so that we can compare two groups is what distinguishes correlational research with differential research. So in differential research, of course, the groups, you will divide participants into two groups. One could be a control group and one could be an experiment group. You differentiate them based on some pre-existing variables. So in differential research, you may be looking at boys versus girls. So you separate the two groups based on gender, which becomes the pre-existing variable. So you are trying to see if better reading skills in boys lead to better math solving problems versus the same issue in girls, right? But here you have to remember that you are trying to find if there is a relationship between these two variables, better reading ability to better problem solving ability in math. Now you are not saying that better reading ability causes better ability to solve math. If you were trying to say that variable A causes variable B, then that becomes a causal relationship. But correlation research and differential research are focusing only on a relationship that exists between two variables, not that one causes the other. Now, many a times, many researchers or my students come up to me and say, or the way they write the paper, it seems like they are saying it's a causal relationship where they say variable, the independent variable is causing changes in the dependent variable. Now, let's take another example here. Now, let's say that you are trying to study if there is a relationship between sunlight and growth of plants. You put plants outside in the sun and you put plants in the shade. The ones which are in the sun are showing better growth than the ones which are in the shade, and you automatically assume that it is the sunlight that is causing the plants for better growth. So you say that sunlight causes more growth in plants. You have made it a causal relationship. Now, if I was reading your research, I would say that did you account for some of the confounding variables? So confounding variables is one of the reasons that correlation research and differential research cannot explain causality between the two variables. So I would say that what if the soil of the plants which was better in the ones which were kept in the sun? What if you were giving the ones which are kept in the sun more water? So here you have to show that the soil was the same, the water given to it was the same, the temperature at which it was kept, the two plants were kept were the same as well. So everything was same other than the sun. So the sun is the only factor which was causing the better growth in the plants. Now it is very hard to establish causality in such cases. It is going to be very hard for you to isolate all the confounding variables and keep only one variable so that you can show causality. Of course, in many other research, depends on your area of research. If you can do that, that's fantastic. There are, of course, causal relationships which are explained. But correlation research and differential research is not the one for it. In correlation and differential research, we only establish a relationship. So taking the same example, we can say, yes, there is a relationship between sunlight and plant growth. But it is not the only cause for the plant growth. It could be soil, it could be temperature, it could be the water intake. So similarly, if you are trying to establish, does exercise cause weight loss? Now, does exercise alone cause weight loss? No. You have to then isolate that if you are investing it among the research participants, you have to keep them on the same diet. You have to think that how is their genetic composition, how much are they exercising, so on and so forth. So for you to establish that only exercise causes weight loss and keep the other confounding variables absolutely constant will be very challenging for you to achieve. So coming back to our original example where I said you are trying to establish a relationship between a student's reading ability with their problem solving ability. Now here you can only establish a relationship that people who are better at reading are also better at solving math, because if they can't read and they cannot comprehend the question, how will they solve the question? People who are slow readers or people who cannot comprehend what they are reading will not be able to understand the math problem itself, so how will they solve it? So of course there will be a relationship between reading ability and being able to solve the math question. However, there are other confounding variables that you may have to think about. One of them is called the Spearman's G factor. Alright, so the Spearman's G factor is referring to the intelligence, the IQ of the student, which you cannot account for. Alright, something that they are maybe born with or something that they have worked on their own time. So Spearman was of course a scientist, and that's why the G factor is named after him. And this G factor is tested through IQ test. You have so many IQ tests, you can test that and you can find out. But that could be one of those confounding variables that is influencing a student's ability to able to solve the math problem. Now that is a confounding variable, so one student may not be able to read as well, but generally having such high IQ that he can comprehend whatever little he has read and solve the problem. So that is where causality cannot be established. So this ability to solve math, although having relatively poorer reading skills or comprehension skills, is then cannot be the cause of it. So you cannot say that people who read better are always good in math solving, or good reading causes better solving, math solving. There could be people who are fantastic in reading, they comprehend, they are good readers, good speakers, they comprehend everything, but they don't have that G factor to solve math equation as well. Alright, so there could be other factors of course which influence a person's ability to solve math problem. So that is why if you are trying to convince the examiners that there is a causality, but the research that you have carried out is either correlational research or differential research, it will be very hard for you to convince the examiners. The confounding variables have to be thought of, and you have to explain how independent variable is cause of the changes in the dependent variable. So that is why I will recommend you that no, the answer is no, causation cannot be explained through correlation or differential research. Do not do that. You have to do a separate causal relationship or causal research where you can easily establish that independent variable is causing changes in dependent variable and no other factors are playing a role in that causality. I hope you understood this video, because often my students do a correlation research and then write the findings and the discussion and the conclusion as if it's a causality, and that will really make the examiners and the reviewers unhappy, and they will find areas in your research which are then weak. So don't do that. Make sure that you have accepted that there is a relationship. You can find the R-square value which establishes the strength of the relationship through of course a regression analysis. You can do that, but if you are claiming to find causality, make sure that you have addressed all the other confounding variables and you can clearly show that the causality in relationship exists. Thank you for watching today's videos, guys. Subscribe, like, share, and I look forward to reading your comments. Bye for now.